Hello, I'm Brian, and I'm Vice President of the ASTRO Club. Recently, we've been meeting to build a radio telescope, and so obviously this is kind of a diagram of something that might exist. And so here, we're hoping to get some kind of dish. We could be using possibly a big dish, that's what we've been looking for, but also we have the idea floating around, as of what I understand at the last meeting, is that we could be using satellite dishes, like, DirecTV, and do a small radio telescope. Then, after that, we're going to have a receiver antenna, and that's probably going to be whatever came with it. But we could also make one, maybe. We could try and figure that out. And then, of course, going to have the cable. And then last, it's going to be our processing. So that could be like an oscilloscope, could be a spectrum analyzer, and maybe it could be a computer. So pretty much what we want to do is first we're going to have a block, because that's just how you do a system block diagram. And this is going to be our dish. Again, as I mentioned earlier, could be a big dish, could be a small one. Then after that, we're going to have our receiver antenna. I think it's whichever one you want to call it. And again, it's probably going to be whatever comes with the dish that we get. Or maybe we have to make one ourselves. And then the rubber cable, kind of important. Without it, you can, between here and the dish and the receiver, it's reflected onto it. But here, we need a cable so we can send whatever signal we get to our processing. So, what is that we expect to see? We're not completely sure, but our best, to the best of our knowledge, right now we're looking at, I guess, what's called flux density. And it's measured in a pretty cool sounding name. It's measured in Janskis. That's actually, watts per meter squared per hertz. So another way of looking at it is it's flux per wavelength. Flux is just going to be, in this case, being as radio waves are electromagnetic waves, or light, it's going to be electricity that's flowing through this area of this and being collected here. And in another sense, it's just electricity that's flowing through a pipe like water. Of course, don't tell my physics professor I said that. And then after that, this flux, this measure of electricity through a pipe, it's going to be per each wavelength. So I believe that's what it means. It could mean something different. So maybe it changes as the frequency goes higher or lower. I'm not too sure, but we'll figure that out. And then after that, so we already know what it is that we're expecting to see. It's probably going to be some kind of flux density, a measure of electricity flowing through a pipe per each frequency. And after that, should probably go ahead and break down the components. And again, some kind of dish, either a small satellite dish like DirecTV or a big one. We see a few, like, the one that's outside the library. That'd be nice. And then antenna receiver, and then a cable. The important thing here is we can't just run Ethernet. We have to use coaxial. It's pretty much, we might not have to, but it's probably a good guess, because there's pretty much two different types of signals that you're going to be passing through a cable. You're going to have broadband, which is analog, and then baseband, which is digital. And an example, this could actually be broadband or baseband, but as soon as you add other kind of waves at the same area in the same time and space, it's actually broadband, because that's more like what we're used to hearing. It's what we had passed through the cable TV back in the day, before Netflix and all that stuff, and that's what we would receive on our televisions, is just a analog representation of the video, and that's probably what our radio waves are going to look like that we're going to be observing with this beautiful telescope. And then, let's see, I'm going to use pink because, computers are pretty. The baseband, which I mentioned earlier, is digital, because the signals you're going to be seeing are pretty much like this. That's why when I said the first sine wave that I drew, it could actually be a digital wave, because it still has its high point and its low point. It's 1 and it's 0. And this is what computers use to talk within themselves. And it's also what you use to communicate with others on the internet. And then after that, back to the processing. We have 3 different ideas. It's going to be an oscilloscope, which is going to be for probably testing. And if we really wanted to, if we're looking at just one of these little sine waves, maybe 2, maybe we could stack them together and get some kind of crazy looking thing, like that. Maybe we can get, punch in some wave form generators and add them together and try and figure out what that is. Or we could just, stick to one frequency, one nice little special wavelength, see how high of amplitude it is, how intense it is, and just be very meticulous in our recording of what kind of frequencies are we receiving when we're pointing the radio telescope at a certain object, say the sun. That's a pretty nice object to point a radio telescope at, especially if you want to make sure there's signal. But after that, then the idea that another idea, but also it's another testing, is the spectrum analyzer. So pretty much it's just a device. It may look like an oscilloscope, but you're able to actually see how each frequency is going. You might be able to see it as it's instantaneously changing, or some spectrum analyzers allow you to see kind of like, it'll just paint like there's not so much intensity for this frequency, and it'll be like, no, that's dark. But then where we actually see some kind of high intensity frequency, that's going to be bright. Again, it could be for testing. It's most likely going to be for testing, since you would have to actually purchase a spectrum analyzer. But we could also try and look to see if we can borrow one from hopefully somebody at the college, maybe like the engineering department. And then, of course, everybody's favorite, our next option would be a computer, and there's likely an app for it with a spectrum analyzer software. And with that, the nice things about that would be that we would have data storage. We would have data storage. It would be scalable, so if we ever made more radio telescopes with the little satellite dish, DirecTV dishes, then we could probably hook them together, and in a way, because the way that radio astronomy works with the radio telescopes, it's a little bit easier to add everything, because instead of like light waves where like it's very small wavelength, they're pretty big, and so the more little telescopes that you stick around, it acts almost like a huge telescope. And if you've already noticed the shirt that I'm wearing, this is for the VLA, Very Large Array. It's in New Mexico, and it's got 27 really, really big radio telescopes that you wouldn't be surprised how fast they move. But because of what they can do, they can scrunch them together. It takes a while to actually move them and stuff like that. They have to move each one. But they scrunch them together and it makes like, a really, really small telescope. And by doing that, they're able to get high resolution in like a certain area. But then when they want to capture like maybe deeper objects, things that they need a huge telescope for, they'll move them, continuously at a periodic schedule to just larger radii of the, if you add it all together, it'd be like a huge telescope. Pretty much they'll just make the radius bigger of the telescope every few weeks, until finally they, actually there's only 4 levels. There's 3, there's 4. 4 levels, and like I think it's A, B, C, and D, and scrunch together, and then D is all the way out, and they gotta like move everything over the train tracks past the highway, and but by doing that, they generate a large telescope. And maybe if we can ever design one of these, figure out how to get it to work, maybe each semester after that we can try and build a few more, because we'll know what we're doing a lot more than we do now, instead of just pretty pictures. But pretty pictures are nice. And anyways, back to the computer with the spectrum analysis software is, again, this kind of data storage. We could record the stuff and we could look at it later. And then it's scalable, so if we wanted to add that array and produce a larger radius, kind of telescope through interferometry, it's what you call it, we would be able to do that and hook it up to a computer. Otherwise you need a spectrum analyzer or a oscilloscope for each one, and nobody ain't got time for that. Then of course, being as we would have a scalable kind of arrangement as well as the data storage, what we could actually do after that is just do further analysis. It's more capable of better analysis later. So we can collect data, last month, the month before, and then compare it with whatever we see today. And instead of having to look through logs that we might generate with the oscilloscope or the spectrum analyzer, we would have it all right there in pretty much all the data that we would have. And so pretty much the way I look at it is, by my calculations, let's see, I had it upside down. I need to restart my calculations, but let's see. Yeah, by my calculations, I think we can finish at least one of these, probably one, by the end of the semester. Thank you for watching, and I hope you stop by the ASTRO Club's radio telescope group. And if you're, electrical engineer, we would love to have you. We need to figure out what impedance matching is and how to do it. That's one of the problems that we would run into. Not only is it, it's pretty much just that one problem is impedance matching, getting the cable to be able to work with the receiver antenna. Because we can always, keep the cable, but we need to do something with the receiver antenna or something in order to make sure that they can talk. So if you're in 116 physics, then hopefully we can figure it out. And then if you're in some kind of engineering class, we would love to have you. And of course, anybody that wants to look at stars, we're here. Unfortunately though, you wouldn't be looking at the stars, you'd just be looking at like, apparently it's going to be like a blur. So, sorry, but we're pointing at stars. Should be good enough, right?